In this video, we are going to talk about naming or classifying polynomials. We do that based on two things. That's the degree and the number of terms. While you are watching the video, you should also be listening to the videos and taking notes in your booklet on pages 1 and 2. So let's start. Obviously, we need to start by putting our name on our booklet, so make sure that you do that. And let's start with a couple of definitions. So first of all, like I said, polynomials are named according to their degree and there we go, and their number of terms. Now, a monomial is the most basic of our polynomials, and this is kind of a long definition, so write small and write neat and squeeze it in on that little space I gave you. A monomial is a number, variable, or product of numbers and variables that have whole number exponents. So for example, 3 is a monomial. X is a monomial. 3x squared is a monomial because 3 is a number, x is a variable. 3x squared is a product of numbers and variables that have whole number exponents. Okay? If you had 3 over x, not a monomial, not a polynomial, because your variable is in the denominator. If you had 3x to the 1/2, my pen doesn't want to write the 1/2. Not a monomial, not a polynomial, because the exponent is not a whole number. Okay, now the definition of a polynomial is, a polynomial can be a monomial, or the sum, that means addition, or difference of more than one monomial. So basically a monomial is one term. My pen, let's try this again. So a monomial is one term. A polynomial is either one term or it can be more than one term. Okay? So for example, we could have 3 plus x. That is a polynomial. It's not a monomial. It is two terms. It is the sum of two monomials. Okay, so just an important note here, and to reiterate what the two non-examples I did at the top, an important note, polynomials have whole number exponents and cannot have variables in the denominator. So our whole number exponents, 0, 1, 2, 3, 4, 5, 6, 7, 8. So no fractions, no decimals, no negatives. Okay? Another important note, something we really need to pay attention to, is that, I'm going to change my color here, terms are separated by addition and subtraction signs. So when I say, not signs, no M, when I say terms, if I have 3, that's one term. 3x, that's one term. 3x minus 6, that is two terms. A 3x and a minus 6, separated by the subtraction sign there. Okay, let's do a little bit of classifying, and these are going to be some vocabulary words for you. So in our first example here, we have one term. When we have one term, we've already learned that one, it is a monomial. Maybe I should have typed these in. Okay, the next example, x squared minus 3. That is two terms, the x squared and the minus 3. Okay, our name for that, like a bicycle has two wheels, is a binomial. Next, 1, 2, 3, 3 terms. We're separated by the addition sign in the first one, subtraction sign in the second pair. So our three terms are y squared, 2y, and minus 8. So that's 3 terms. And just like a tricycle has 3 wheels, a trinomial has 3 terms. And our last example here, 1, 2, 3, 4. 4 terms, and at this point we just say 4 terms, 5 terms, 6 terms, etc. I'm sure there's a name for it. I don't know it right off the top of my head. It's not important because we're just going to call it by the number of terms it has after we get over trinomial. Most of what we do will be dealing with those three: the monomial, the binomial, and the trinomial. Okay, moving on to our second criteria. The second thing that polynomials are classified by or named by is the degree. So let's start with just our general definition of degree. And it's kind of wordy and a little difficult to understand, so we're going to break it into parts, but let's write this one down first. The degree of a polynomial is the greatest sum, remember sum means addition, of the exponents in each term. So we're going to be adding exponents together here. Okay, and I said we're going to split it into two. We're going to look at first the monomials, and then second the polynomials. So first we're going to look at the ones with one term, then we're going to look at the ones with multiple terms. Okay, pause if you need to finish writing that down. I'm going to go ahead and move towards talking about our monomials. In a monomial, to determine the degree, you simply add the exponents. So if I have, I'm going to do a couple of examples here. If I have 3x squared, okay, I don't need to add any exponents because it's just the 2. The 2 is the only exponent, so this has a degree of 2. That's our degree. If I have 3x squared, I don't know why it doesn't like to write that squared. Let me try it again. If I have 3x squared y cubed, this time I need to add my exponents. 2 plus 3 is 5. So that one has a degree of 5. Okay, let's do another one. Let's do negative 6xy squared. Negative 6xy squared. This one's a little tricky. We've got to be careful. Remember that x has an exponent of 1. So this is 1 plus 2. This one has a degree of 3. So with monomials, you are simply going to add your exponents. Now, with a polynomial, what you're going to do is find the degree of each monomial and then take the highest. So go ahead and write that down. And then let's talk about what we mean. This is the one that goes back to our general definition. So find the degree of each monomial, so that's the sum of the exponents. Then take the highest, that's the greatest. So you're going to take the biggest one. And what I'm going to do here is I'm just going to take my 3 monomials and I'm going to put them together for my example here. So if I have 3x squared plus 3x squared, darn this pen, 3x squared y cubed minus 6x y squared. There we go. I take each individual one. So this has a degree of 2, this has a degree of 5, this has a degree of 3. My highest is 5, so this one has a degree of 5. So with the monomials, you do the sum of the exponents. With more than one term, with the polynomials, you do the sum of the exponents in each term and then choose the highest. So notice I did not go 2 plus 2 plus 3 plus 1 plus 2. I didn't just add all the exponents. I added within each term, and then I chose the highest. Okay? All right, let's take a look at some examples, which this is where we're going to get our vocabulary. And I want you to notice here, all of these only have one variable. So I'm not going to need to do any adding. I'm just going to be choosing the highest. Okay? Now, the first example is a little bit tricky because there's no variable. Anytime there's no variable, it's a degree of 0. And the reason that that's true is because x to the 0 is equal to 1. So I don't write the variable because it's 1, right? A degree of 0, we say, is a constant. Because 3 is not varying. It is constant. Okay. For the next example, this is a degree of 1. This is a degree of 0. The highest of those is 1. And a degree of 1 is linear. Okay. So these are our vocabulary. Constant, linear, this is vocabulary. All right, next example. Degree of 2 for the first term. 1, 0. 2 is the highest. 2 is the highest. So I'm going to do 2. And our word there is quadratic. We will spend a lot of time on linear and quadratic. In fact, I would say that's where we're going to spend most of our Algebra 1 year. Okay? Next, degree of 3, a degree of 1, a degree of 0. 3 is the highest. That is cubic. We could also say third degree. We could say second degree, first degree, but typically we'll use the words constant, linear, quadratic, cubic. Okay, so here we go. 4, 3, 1, and 0. 4 is the highest. There's a word for that. It is quartic. But truthfully, what we usually say is fourth degree. Once we get above 3, we typically just say fourth degree, fifth degree, sixth degree. Okay, so here we have 5, we have 3, we have 1. It's a degree of 5. Again, there is a word to that, quintic. But you don't really need to know that, I'm just telling it. What we will typically say is fifth degree. And then in our last example here, that's a degree of 6. That's a degree of 3. So 6 is the highest. I don't even know the one for 6. I'm sure there is one, but I don't know it off the top of my head. So we'll just say 6th degree. Okay, I want you to try these at the bottom of the page. You are labeling it, classifying it, naming it based on the degree and the number of terms. Okay, I'm going to help you with the first one. So the first one, by degree, there's no x, so it is constant. By number of terms, there's one term, so it's monomial. So for each of these, it'll be 2 words. One from the first table on page 1, one from the second table right above this. Okay, good luck.